Okay, welcome back, and this little talk and demo is about blind source separation. It's done on pseudo real time, and what I'm going to demo is I've got two microphones which feed into an amplifier, and that goes into a sound card, and that goes into LabView. It's not running real-time LabView, it's not running Rio or anything, just a straight PC. The idea is that each microphone will pick up a source. Here's Kyle and Stan, but in my case it's two radios running continuously, and of course each one of these will pick up, well, that microphone will pick Kyle up and Stan via some kind of transfer function and possibly reverberation off the walls. And likewise this microphone will do the same. The purpose of the exercise is to pass this through a computer algorithm in real time to separate them so you get Kyle and Stan separately. Of course, it's not a trivial thing to do this. There are many ways to do it, and I've already demoed one method which isn't that good, using voice activity detectors. This method doesn't use a voice activity detector. It uses cross-coupled least mean squares algorithms. It's called a crosstalk-resistant adaptive noise canceller, CRANC, crosstalk-resistant adaptive noise canceller. Here's the setup down here, if you can see it. Two microphones, two radios, not switched on at the moment so you can hear what I'm saying. The radios are relatively close to the microphones. If you put them too far away, you need very long filter lengths, I've found, so the results aren't quite so good. So there's another drawback. But so they're relatively close, so we can think of such an application. Of course, you could extend this idea to more than two, and the theory of blind source separation or independent component analysis, it does exactly this. But this method doesn't use that. It's quite complicated, blind source separation, in the sense that computationally it can be quite a burden. So I think I can quite easily implement two LMS algorithms in real time. Each one of them is going to have weights of 1,000, which is quite a lot. Now there will be a latency, of course. I'm not pretending it happens instantaneously. Here's the program here. It's also called a symmetric adaptive noise canceller. Okay, and the thing that does all the magic tricks in here is the dual LMS, the cross-coupled LMS, the least mean squares. And what this is two least mean squares algorithm, if you understand least mean squares, that is, running, well, theoretically they're not running in parallel because they're not running on an FPGA. They're running together, and one's output of one's feeding into the error of one's feeding into the input of the next. This method goes back to the late 1980s, early 1990s. So I'm going to demonstrate this working, and it kind of shows the usefulness of LabView for this kind of thing. I'm not suggesting you'd use this for a final product, but for experimentation this is really very little to touch this kind of thing, how I can read the data in and so on and play it back. I'm actually going to record the data, as I'll explain in the next section, because if I play it back at the same time, it interferes with the sources and I get feedback, which is quite difficult. It's difficult enough as it is, so I'm going to record it, and so I put a little fiddle into the program that I can record the outputs when I switch between the channels. So I'm going to sort of, hopefully, you know, the two radios, one should appear in channel 1 here when I flick it, and one should appear in channel 2. Of course it won't. You'll always hear crosstalk from one to the next, even though it's called a crosstalk-resistant noise cancellation method. There'll always be some interference from the other channel. In this case you might find that one channel is better than the other for some reason. Arbitrarily chose the step length for least mean squares algorithms to be 0.0001 and 1,000 weights in each LMS, so it's two LMS algorithms running together, which is quite impressive, but of course it is a Pentium PC. So the next section will be the demo, and we'll see that. Okay, now for the demo. And it was a little bit tricky to do the demo because I've got two radios down here which are playing live, and if I play out a loudspeaker then I get feedback through the microphones and a big howl. So because of that I'm going to have to record, although it's sort of recording in real time, I'm going to record it and play out the results. So once again, the two sound sources are radios just playing live, two microphones, and each microphone will pick up the sound from each one of those, and it's a stereo input into the sound card, and then into LabView. There's no real-time RIOs or anything, so it's really pseudo real-time. And what I'm going to do is hopefully switch the canceller from one channel to another, and let's see if we can separate, do some blind source separation. So I'm going to put it on record. So that's channel 2 at the moment. So when we play it back we should hear just one channel with a little bit of the other in the background. Switching it to channel 1. And that's back to channel 2. I can play both of them just to show there are both there. And that's it. Now I'm going to turn off the sources because again, hearing 3 radio sources altogether, the 2 from the radio and 1 from the playback, is a bit off-putting. So we'll go down here and turn these off. That's the first one off. That's the second one off. So I'll play them back. Turn up the volume now. Unfortunately it's still picking up the my voice, so it'll still give feedback off my voice, but I'll try and keep my voice to a minimum. First channel. Second channel.
Christmas New Year period using those Asian ingredients. And I'll tell you what I'll let you do. If you want to...
Back to the first channel. And then I think both together coming up. Both together. Back to one channel.
Preparing something festive for the Christmas New Year period using those Asian ingredients. And I'll tell you what I'll let you do. If you want to...
Back to the other channel.
I don't like to, but I hope there's some other yummy where I'm going.
And that's both of them. Okay, that's the end of the demo. I hope you could discern that. It's a little bit tricky to see what's going on. Thanks very much. Bye-bye.